Okay. So in the last class, we have discussed about the common emitter amplifier with unbypassed emitter resistor. Now we'll go back to our fixed bias circuit. So in that circuit, we are going to add this RE and see what is the effect. Okay, last class, last amplifier, if you see, this RB will not be there. You will just have RC, RE along with the source. But now what we are doing, we are trying to add this emitter resistance to fixed bias circuit. You know, a fixed bias circuit is will have two resistance RB and RC, and you will have emitter connected directly to ground. But here what we are doing, we are connecting this RE along with the fixed bias circuit, and we are going to see what is the different four parameters we have, right? Voltage gain, current gain, input impedance and output impedance values are going to depend on RE. Okay, so first, and you also have, you see, we have the coupling capacitors here, C1 and C2. At the input, you have one coupling capacitor called as input coupling capacitor. At the output, we have one more coupling capacitor called as output coupling capacitor. So since this circuit is going to have a lot of AC components, so first we will be drawing the AC equivalent circuit, and from the AC equivalent circuit, we will be proceeding to draw the H parameter equivalent circuit. So in the previous case, we did not have any capacitor, so we directly drew the H parameter equivalent circuit. But since here we have the AC components, the coupling capacitors C1 and C2, so from the circuit diagram, we would be drawing the AC equivalent circuit. From the AC equivalent circuit, we will be drawing the H parameter equivalent circuit and simplifying that circuit. Okay, so that is the method of analyzing this transistor. Okay, so see that from the now we have drawn the AC equivalent circuit. AC equivalent circuit means you have to short circuit all the capacitors and voltage sources. So the capacitor C1, C2 will be shorted. Voltage source will be connected to ground. Okay, VCC will be connected to ground. So in the diagram you see, this is our transistor and RE is connected to ground. RB was between base and voltage source. Voltage source is connected to ground. So RB will be between base and ground. See here, RB is between base and ground. Already we have RE between emitter and ground. And RC, you see, RC was connected between collector and VCC. VCC is now grounded. So RC is also between collector and ground. And you measure output across RC, which is your load resistance. And input impedance is measured here. Output impedance is measured here. So this is our AC equivalent circuit. Any doubt in the AC equivalent circuit? Any doubt in the AC equivalent circuit, what we have drawn from the circuit diagram? It is very simple. Only two steps we are going to follow. One is short circuit your sources, voltage source. If you have current source, means you have to open circuit it. Okay, here we have only voltage source, so we are short circuiting the voltage source. Then all AC components like inductor, capacitors will be shorted. Now, for use with that approximation, if you draw the diagram, that is going to be your AC equivalent circuit. From AC equivalent circuit, we will be drawing the H parameter model. See here, this is the H parameter model. So HIE, HFE, will be there. This is for all transistors. Here you will have RC, and here you have the emitter resistance RE, and here you have the base resistance RB. So this is your input voltage. You measure output voltage here. It is same as the previous diagram, but previously, you know, this HIE and current source were drawn horizontally. Now they are drawn vertically. So nothing much difference you have. It is going to be the same. Okay, so remember in the previous case it was drawn horizontally, now it is drawn vertically. All are going to be the same. And last circuit we did not have this RB, we just had only HIE, right? Here we have this RB extra, and RC is your load, and across RC you measure V0. V0 is always the upper, we measure the positive negative like this, and depending on the current direction the expression will have minus sign or plus sign. Okay, so this is our H parameter equivalent circuit, and same thing, you know, IE is equal to 1 plus HFV into IB. So this also we write everything in terms of IB, because that will be simple for us. The first one, input impedance. So input impedance, for input impedance you have to consider the input side. Okay, so consider the input side.